So in this lesson, we're going to talk about our next type of transformation, which is reflections. And reflecting functions across x and y axis are important mathematical process that will be explored in this lesson specifically, but they can be applied to any type of function. And if you remember, reflecting functions is very similar to how we reflected in geometry. So let's take a look at these reflections. So we're going to graph y equals negative x squared in our calculator and then sketch the graph to the right. So I'm going to go to Desmos and type in y equals negative x. Right? Yes, that's the parent function, so y equals negative x. Y equals negative x squared. And there is what our function looks like. Again, you can just plot the main points here. So when we plot it, it looks like this. I'm going to plot it in orange. The turning point is still there. And again, a hint to when you graph is you plot your vertex and then you just go down one, right one, down three, right one on that side. And then you go down one, left one, down three, left one, and you can quickly sketch the graph. Okay. Sorry, this doesn't let me erase lately. So there you go. What seems to be the transformation from the parent function? Well, it looks like we reflected over the x-axis. Looks like we took the original parent function and flipped it over the x-axis, and flipping is the same as reflecting. So now, in our calculators, let's put the negative on the inside. So we're going to do negative, and it looks like nothing changed. That's because we actually reflected over the y-axis. Because quadratics are symmetrical, and the y-axis is going right down the middle. So when you flip it, it's going to land in the same spot. So everything's going to look the same. So this is actually a reflection over the y-axis. Because if you remember from geometry, if we're reflecting over the y-axis, this point right here is 1 away, so we count 1 in the other direction. Same thing, this point's 1, 2, 1, 2. They're the same distance from the y-axis, so everything just kind of maps back up on to itself. So whenever you reflect the parent function over the y-axis, nothing really changes. So that's important to note. So here's a parent function of the square root of x. We'll get more into these functions later on in this year. But again, let's graph this in our calculator, negative square root of x. So y equals the negative square root of x. And there it is. Again, it looks like we reflected it over the y-axis. And if you need help graphing this one, if you hit the little wheel and then hit the table, there's some points you can graph. So you just like plot those first like 3 points, kind of, and then plot it. So you have 0, 0, 1, negative 1, and it will look like this in green. Again, it looks like we reflected over the x-axis. Here, we'll see the reflection over the y-axis better. I'm going to put the negative on the inside with the x. So now we're going to graph y equals square root negative x. And there's where you can see it a little bit better. And again, if you need more points to plot, hit the wheel, hit the table, and plot points. So I'll plot this in orange. 0, 0, negative 1, 1. Negative 4, 2. So it's like this. So you can see it a little bit better. We reflect it over the y-axis. You can't really tell with quadratics, but you can definitely tell with square roots. So this is a new type of transformation. So you have negative f of x. So when the negative's out in front, it's a reflection over the x-axis. When the negative's on the inside, it's a reflection over the y-axis. So outside is x, inside is y. Okay? So let's take a look at some examples. Here we want to state the vertex of each of the following parabolas, list transformations, and then sketch a graph. So when we do this, and actually I'm going to stop here.